In this tutorial, we will explore a clinical data file provided on Surface Workbench using Python. Our primary goal is to understand the structure of the PIC-SURE exported EHR clinical data and introduce basic data analysis techniques to help you get started with your project. The types of variables included in your dataset depend on the selections made during the data export. In general, the dataset may contain demographics, diagnostics, medications, lab results, and procedures. The following sections we will explore these categories and perform basic analyses. The exported PIC-SURE dataset consists of 5 key columns: patient num, a unique identifier for each patient; concept path, which represents the clinical variable for a given observation. For example, a row with the concept path demographics/race represents a patient's race. 3. The t-val-char column, which is the text or character value of the clinical variable, if applicable. The n-val-num column, which is the numerical value of the clinical variable, if applicable. And finally, the timestamp column. This is the date and time associated with the observation. Demographics. In this section, we will organize, analyze, and visualize demographic data including age, sex, and race. We can create a histogram to visualize the age distribution in our dataset. A table or bar plot can help us summarize and display the distribution of race across our patient cohort. Diagnostics. The diagnostic data is recorded using ICD-10 billing codes. In this example, we will investigate epilepsy as the disease of interest, which is represented by the ICD-10 code G40. In clinical research, it's common to look at multiple conditions at once. This kind of analysis is key when you're interested in comorbidities or overlapping health conditions. Here we investigate patients diagnosed with both epilepsy and migraines, using a filtering approach that allows us to handle multiple diagnostic codes. For example, we can create a data frame displaying the patients diagnosed with epilepsy and adding a column to indicate whether or not the patient has a migraine diagnosis as well. This analysis helps assess prevalence and can serve as a foundation for further investigations. Medications. This section focuses on analyzing medications administered to the epilepsy patient cohort. It is important to note that the dataset record medications administered to the patient on a specific date and time. They do not include chronic or daily prescriptions. Here we create a list of all medications administered and filter for a specific drug of interest. Lab results. Here we analyze lab results by first listing available tests. Then we can search for a specific lab. In this example, we are looking for aspartate aminotransferase, AST, and alanine transminase, ALT, from the year 2023. We can interpret the results using summary statistics for ALT and AST in a table or box plot for distribution. We can also analyze the trend analysis for individual patient changes over time. Procedures. Procedures are recorded using CPT codes, which stand for Current Procedural Terminology. Similar to previous sections, we first generate a list of all procedures in the dataset. Then we filter for a specific procedure performed within a given time frame. In this example, we investigate all appendectomies performed in 2020. This tutorial provided a foundational understanding of EHR clinical data and how to analyze it using Python. For a more detailed explanation and review of the code, please refer to the Basic Analysis in Python video. If you need additional help, please submit a help desk ticket using the GIC service desk.